Hello my dear class 10 students, I welcome you to NEET World. So this is our lecture number 5 on acids, bases and salts from class 10th, right? So let us continue with our discussion. In the last class we have discussed about the weak acids and strong acids, weak bases, strong bases, and degree of dissociation. Depending upon this degree of dissociation we have classified acids as strong and weak, bases also similarly we have classified. Then later we have came across some general applications, right? So now what are the industrial uses of these acids? See, hydrochloric acid, okay? So this will be used in making dyes, as well as see here cleaning of metals, tanning, okay, in printing. So in this purpose, again sulfuric acid, which is also called as king of chemicals. So we will be using it in a very different vast number of applications are there, like for manufacturing of fertilizers, chemicals, okay, and also dyes. So what are these dyes? So you know we will be wearing some different class like jeans, blue jeans, black jeans we are wearing now. So for that we will be using colors, right? So for manufacturing of those colors, that is what dyes you can understand, okay. And also plastic industry, see, and making of batteries also it will be used, okay. Again when it comes to nitric acid, that will be used as in the manufacturing of fertilizers, as well as explosives like trinitrotoluene, TNT in the short form we can call, and also tear gas. So where do we use this tear gas? See, whenever some heavy crowd is taking we will be seeing generally in the movies and news, like whenever the crowd is unwantedly gathered at one position. So what happens? The policemen may use some balls which are contained, or some gas which is nothing but tear gas. So that may used in the to avoid this crowd and all, so that may used by this policemen, okay. So that will causes them to feel uncomfortable there, so they may go from there. So this is what happens. Again acetic acid, so where do we use this? So acetic acid will be used in the vinegars, right, and also in the food preservative we will be generally observed. So this is about the general applications. And also what are the general industrial applications of bases? Sodium hydroxide, which is called as caustic soda, potassium hydroxide, which is called as caustic potash. So these are used in the manufacturing of soaps, right, like soft soaps, hard soaps. We will be studying about that. So generally potassium containing soaps are considered to be soft soaps, okay. So the next, calcium hydroxide, this is used in the removal of hardness of water. Removal of hardness of water means what? See, in water, so if you take it from ground source, so it may also contain some salts like calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. These kind of salts will damage the utensils, and also it is very harmful, okay. So in order to remove this, for example, if you heat the water, sometimes to that whatever the utensil you are using, or even you can observe for the water heater, so after few days you will be seeing some white color scale which is accumulated on the that utensils or the water heater. So this is nothing but the salts, okay. This magnesium chlorides or calcium chloride, this kind of salts. So this is very harmful, and also damages the this whatever the utensils vessels we are using, okay. So it is very it is very important to remove that hardness causing substances. So for that purpose we will be using calcium hydroxide, CaOH twice, okay. And it is also called as slackle lime, okay. Next, magnesium hydroxide, this is previously it was used as an antacid. So what is this antacid? See, if a person is suffering with acidity, so in order to neutralize that, this antacid tablets, this magnesium hydroxide was taken, okay. So now what it will do? It will neutralize the acid in the stomach, okay. So this will not cure the disease, it will just neutralizes the acidity, okay. So it means it is only for temporary purpose, okay. It will not cure him from the disease. So it is always recommended to take proper prescription from the doctor instead of taking just a normal antacid tablets, okay. So again ammonium hydroxide, NH4OH, so this is used for removing of grease stains from the cloths, okay. So these are the general applications. Okay, then next I have a question for you. So these questions are based on the previous session discussion. That is, we have discussed about acid base theories now. So what are the acid base theories we have studied? Lewis acid base theory, Arrhenius acid base theory, Bronsted acid base theory. These are the things we have studied. From that if you understand, see, the following reactions occurs in the aqueous solution. Predict the products formed and identify the acids and bases and respect to conjugate acid and conjugate base pairs. Okay, so here this compound will react with this and forms some products like this: sodium like acetate ion and ammonium ion. These are the species formed. So what happening here? See, ammonia is a base. Okay, so how it will be a base? According to Lewis acid base theory, see, electron pair donor is considered to be Lewis base. Okay, and according to Bronsted acid base theory, what we know, the proton acceptor is a base. Bronsted base means what? Proton acceptor. Again, Bronsted acid means what? Proton donor. See, this species will donate a proton from here, H plus ion from here. So I can say this is a Bronsted acid. Okay, this H plus ion is accepted by this ammonia lone pair. So I can say this is Bronsted base. Proton acceptor is Bronsted base. Hope it is clear. Okay, so now after releasing this H plus ion from this acid, now the negative part is there now. Since it is an acid, the negative part of it is called as conjugate base of this acid. So Cb means what? Conjugate base. Okay, conjugate base in this reaction. Now this is a base. After accepting this H plus ion, now it will be forming a cationic ion like that. So you can call it as conjugate acid. A base by accepting proton forms conjugate acid, respect to conjugate acid. So now here you want to remember one important point: a base and its conjugate acid and acid and its conjugate base differ by one proton itself. That's it. Only they are differ by one proton. Look here, the base and its respect to acid. See, NH3, NH4 means they are differ by one H plus ion. That's it. Similarly, applicable for this acid and this base, they just differ by one proton. Now I want you to answer these two things, B and C, which is acid, which is base, what is its conjugate acid and conjugate base, in the comment box. Okay, so the next, ammonia does not contain hydroxyl group, then how we are calling, why it is a base? So what is the answer for this from your side? So what happens, you can try your answer in the chat box. By how can you get this answer? Yes, so you need to study about Arrhenius acid base theory in order to answer this question. Okay, so where do you get that? Yes, in the previous session itself I have explained this acid base theories. If you watch that, yes, you can definitely answer this. Okay, so watch the session number lecture number 3, you can get the answer for this question. Okay, yes. Then the next, strength of acids and base, like acid base solutions. See, strength of an acid, it is nothing but the capacity or the tendency of that particular substance to release the H plus ion. More the number of H plus ions are released by that substance, more is its acidic strength. Similarly, more the number of OH minus ions are released by a substance, then stronger is that particular base. Okay, stronger is its basic nature. Okay, hope it is clear. So strength is nothing but, strength is directly proportional to number of H plus ions released by acid, that is what acidic strength. Similarly, number of OH minus ions released by that base, that is what its basic strength. Okay, so now there is something called universal indicator. This is just mixture of all the different indicators. Okay, so now when this universal indicator is taken, see, it shows different colors based on the pH. So what do we mean by pH? Yes, we are going to that, just hold on for some time. Okay, so the larger the number of H plus ion produced by an acid, stronger is the acidic strength of that particular acid, and we are considering it as strong acid. Similarly, strong base, if it is releasing more number of OH minus ions. Now here you have came across a word pH. So what is this pH? See, pH, in this pH, the term P indicates here, P indicates what? Potential or potence. Okay, so this is a German word which means power. P means what? Power. H means the power of H plus ion. Okay, so H plus ions are coming from acid now. The power of H plus ion that is coming from an acid is its pH. Okay, now this pH scale was given by whom? It is given by Sorensen in 1909. Okay, so this is designed by this person, Sorensen. Okay, so what it indicates? pH is used to represent the activity or the concentration of H plus ions in the aqueous solution. Okay, pH can be defined as, how we can define? So pH can be defined as minus logarithm of reciprocal of H3O plus ion. Simply we can say H3O plus ion, or simply you can write H plus ion. Since we are defining it in the aqueous medium, H plus and H3O plus ion both are same only here. Okay, so minus logarithm of reciprocal of, not log, minus, so here I can write directly pH equals to log of reciprocal of H plus ion concentration. Like this you have to write, or you know, I hope you know log of 1 by A if we have, so we can also write this as log of A power minus 1, right? So this A power minus 1 we can write it as minus 1 log A. Okay, minus 1 log A. So similar story you can apply here. So it will also become minus log concentration of H plus ion. That's it. So this is the pH formula. Directly you can use this. pH equals to minus log of concentration of H plus ion. So this H plus ion concentration should be expressed in terms of normalities. Okay. Then next, here one more thing you need to understand. See, pH scale I am saying now. So this scale varies from number 0 to 14. From where to where it will be varies? 0 to 14. So the center part here, the 7 is considered to be neutral point. Okay. So this story what I am explaining, this is at the 25 degrees Celsius. At what temperature? So at 25 degrees Celsius. It means what? If we change the temperature, the numbers on this pH scale, it means in the neutral point may also varies. The like here we have 14 now, so this number also changes. If I take it 90 degrees, the number becomes 0 to 12. It means the neutral point here we are considering it as 6. So this is what happens, the effect of temperature. Okay, so pH scale is a temperature dependent. If temperature changes, pH scale conditions are also changes here. Okay, hope it is clear. Let us understand this at the 25 degrees Celsius first. Okay, so from 0 to 7 I can say this is acidic region. What is this region? Acidic region, and the 7 is considered to be neutral. What is this? Neutral. Okay, neutral. And after 7 we can consider this as basic region. Okay, so from as we moving from 0 to 7, acidic nature decreases and 7 becomes neutral. From there basic nature increases. It means the strong acidic region is where near to 0, towards 0 is strong acidic region. Okay, and nearby 7 it is weak acidic region, and above 7 basic. It means around this around near to 7, that is 7.57, 7.18, this is weak basic region, and 14 is a strong basic region. Hope it is clear. Okay, this is about pH scale. Okay, so the next one more thing, less is the value of pH, more is the acidic nature of that particular substance. So lower the pH value, more is its acidic nature. This is what you need to understand. Okay, then next let us move further here. See, generally we have some substances, some chemical, like some common solutions we are using in our daily life. So what is the pH and how can we give the pH value? See, gastric juice, okay, which is present in the stomach, having pH range like this, 1 to 3. Okay, this is a pH range. Soft drinks like Coca-Cola, Thumbs Up, all of this having pH range like this, acidic only, 2 to 4. Lemon will be having this one, 2.2 to 2.4. Vinegar is having 2.4 to 3.4. Apple, okay, this much. And urine, again acidic 4.8, okay, and varies up to 8.4. Okay, rainwater 6.0. One note point here for the rainwater is, so if the pH value is lesser than 5.6, we can consider that particular water, the rainwater as acidic rain. That particular rain as the acidic rain. Okay, so why this as like rainwater is having pH 6, why not 7? Because in the atmosphere carbon dioxide is present. Whenever this rainwater interacted with carbon dioxide present in the atmosphere converts into the acidic solution, right? Carbonic acid is formed. So due to this reason, so when they fall on the ground, whatever the water, if we observe, the rainwater will be seems to be acidic. That is what the pH is around 6.0. Now along with carbon dioxide, if some other acidic oxides like NO2, SO3, SO2, these are present, those are also converted into respect to oxo acids like nitric acid, sulfuric acid, right? So if that happens, so that results to decrease in the pH further. It means if the pH falls lesser than 5.6, what we are considering it as acidic rain, acid rain. So this have a very bad, like I can say very bad effect on the atmosphere as well as the human body and also aquatic life. It will damage the skin of the animals and humans, as well as it will change the pH of water in the lakes, so that it will affect the aquatic life also. These are the general things you need to know. Again, soda water will be having pH less than 7. Next, milk will be having around 6.6 to 6.3 to 6.6. Saliva, okay, human saliva is having 6.5 to 7.5. Human blood is having slight basic range 7.3 to 7.5. Milk of magnesia 10.5, okay. So seawater 8.5, alkaline. Black coffee having 5.0, okay. So that's why doctors recommend not to take coffee, tea during if a person is suffering with the acidity, okay. So because already it is acidic in the body, again if we take this acidic solutions, make more acidic na, so this is make him to suffer more, okay. That's why it is not recommended to take when a person is suffering with acidity. Next, tomato, so 4.2, and tears, so eye tears, so it is having slight alkaline 7.4, okay. So now one more concept here you need to know, pH value of like when two or more acidic solutions are mixed. For example, I have acid 1, okay, and acid 2 I have having concentration N1 and volume V1, here N2, volume V2. So when we mix these two, so what happens to the solution? See, volume will become total, V total will become V1 plus V2, and its concentration also changes now, because I have a beaker. To this I am adding acid 1, acid 2. So both are having different concentrations. Now the resultant concentration also varies now. So N resultant concentration should be taken like this. So N1, it means concentration of acid 1, and V1, volume of acid 1, plus N2, concentration of acid 2, V2, volume of second acid, okay. So V total in the denominator, V1 plus V2 you have to take. If to the same beaker, if we add some amount of water, so some V amount of water we have added, so now V total becomes what? V1 plus V2 plus V amount of water, whatever you have added, take that is what the V total it becomes. Hope it is clear. Now I am giving a question for you. See, this is the question I am giving for you, so you need to try this question. Just use this formula and give a try to answer this question, and the explanation for this question will be given in the next session, okay. So I will be providing answer in the next session. If you want, you can give a try from your side and tell me in the comment box. So thank you for watching. I hope you really enjoyed the session. If you really enjoyed, just click on the like button and also share with your friends. Thank you.